YouTube. What you're seeing is star trails that I shot last night with my P900, and I've looped them over and over again, and some of them they're slowed down, some of them they're regular speed, and my camera is facing the east, so north would be to the left side of the screen. So the reason why I wanted to show you these tonight is that if you're like me and you're old, and when you were in school you were taught that the sun was stationary and that the planets revolved around the sun. And so looking at these star trails, you would say, okay, well, that's the Earth's rotation. However, that's not what modern astrophysics says about the universe today. It says something completely different. It says that the sun is actually moving across the galactic plane. So these images you may be familiar with. There's a video going around YouTube, and it's a 3D simulation of the sun, the planets moving through the galactic plane. So this was something I wanted to discuss at great length. If we're rotating around our axis at 1,000 miles an hour, and we're orbiting the sun at 66,600 something miles an hour, and then we're moving through the galactic plane at 580,000 miles an hour, it would be impossible to record star trails like what you just saw earlier in the video. Those would be very difficult to get because the stars would be shooting everywhere. Really, I don't know that we would be able to even see stars as fast as all of that's going. All these images you're seeing are from a website called universetoday.com. It's a whole article, and I'll leave links in the description. But there was one of the astrophysicists who does not agree with the video or the model, because he says that the sun, it was leading the planets, and he said that's not always the case, that the planets sometimes lead the sun. So he came up with a picture to more describe what he believes it looks like. So here's his depiction of what that looks like. Now, his doesn't show any motion like the other video, but they go back and forth in the article about what is right and what's wrong and all of that. So I'll leave a link in there. You can go read it for yourself. It's really a fairly interesting read, especially if you're new to the fact that we are traveling through the galactic plane at 580,000 miles an hour. Now I want to show you some images from some satellites, and I recommend that you try this for yourself because it's very interesting. Okay, we're going to pick a spot here in the Houston area. And we're going to tell Google Maps to measure distance. We're going to go over here to Western Sahara Desert in Africa, and we're going to pick a spot there. That distance is 4,919.70 miles. And you can see it gives you this big arch. And down here are the Cape Verde Islands. And up here the Azores Islands. And so now we're going to get this map to look like this. This is the NOAA's geostationary satellite server, and this is the tropical sectors, and you can see that they've got all of the lines for the degrees on here, longitude and latitude, 10 degrees, 20 degrees, 30 degrees north, 30, 40, 50, 60 west, and they're all running parallel and perpendicular, and this looks flat. So you can see that the western section of the Texas Panhandle is cut off, and the tip of the Upper Peninsula of Michigan is cut off. So we're going to try to make this map look like that map. So we're going to come and we're going to cut the tip of the upper tip of the Upper Peninsula of Michigan off. We're going to cut off the left side of the Texas Panhandle. Now this is pretty close. You can see that we can see the northern tip of South America down here. So then we can see Cape Verde Islands. We can see the Azores over here. So we've got all that in view, and you can see we're at about 4,000 miles according to Google Maps where our other satellite image cuts off. So that's about the distance that this map covers. Up here you can see the Azores. Over here you can see the tip of the Cape Verde Islands. This black spot's always here in this. I use this website a lot. I have for many years. Some very interesting things though to look at. All the land looks flat. All the lines are parallel and perpendicular. Now we're going to go back over here to Google Maps. We've got our Google Maps set at about the same place as the NOAA map that we were just looking at. Now we're going to click on the satellite imagery in Google Maps, and there we have our distance over to the Western Sahara in Africa. Now you can see our satellite image in the NOAA cuts off over here at about 4,000 miles. Now we can see Arizona, Utah, we can see all the way over to California in this view. So what we're going to try to do is we're going to try to get this to where we cut off the upper peninsula of Michigan and the western part, which you can see the Texas Panhandle is moving at an angle like this. Up the screen, I don't know if you can see that. I hope you can. So this is about where this satellite image looks. I've got the upper peninsula of Michigan cut off. You can kind of see the panhandle of Texas. It's all at different angles and crooked and everything else. Now, over here we can only see about 3,000, a little over 3,000 miles, and we can't see Cape Verde Islands, the Azores. We can't see any of those from this angle. And this is supposedly a satellite image. We can't see the northern tip of South America. We can't even see all of the Yucatan Peninsula in this view. And then we have to roll the map around way over here to be able to get to see the Cape Verde Islands and the Azores. So I wanted to show you this because it's very interesting. I use the NOAA website, like I said, a lot. So this should be about where that satellite is. If I zoom out, I'm looking at almost all of California. And if I roll it around to where the Texas Panhandle's cut off, it's going way around the curve. So let's set it like that. I still can't see the northern tip of South America. Let's zoom out where we can see the northern tip of South America. Now let's cut the upper peninsula off of Michigan and roll Texas around where you can barely see it. Now this all looks kind of like that. This is actually what they use for tracking, predicting hurricanes, things like this in the Atlantic Ocean. So this looks very different from that. So it was something interesting I thought you should see. Try it for yourself. I suggest you do. Now, before you go start hammering me on my videos, I don't have cable and I don't have internet. I don't have any of that stuff. I got rid of all that stuff years ago, like 5 years ago, maybe more. So, but I still work at putting videos together, and it's very time consuming for me. And I work a full-time job and get up at 5 in the morning. So, but one thing I want to stress is that everything I've showed you in this video, go look at it, go research it. Is the earth flat? You tell me. Is the evidence I showed you tonight, does it suggest that the earth is flat? Or does it suggest that we're living on a ball? Something to consider. Just go look, take a look, do some research. And please, like always, let me know your thoughts in the comments. Thank you.